Hi all, I'm T. Shaktishri, Assistant Professor of Department of Information Technology, Hindustan College of Engineering and Technology. Welcome you all for a session on Introduction to Data Structures. In this session, we are going to learn about the definition of data structure, the various classifications of data structure, and comparison of linear and nonlinear data structure, followed by what an abstract data type is and what are the various implementations of data structures. First, let us understand what a data is. Data refers to the fact or information or knowledge which has been represented for better usage or processing. The computers are electronic data processing machines, and in order to solve any particular problem, we need to know how to represent the data in a computer, how to access them, and what are all the steps to be performed to get the needed output. So, these steps or these tasks can be achieved with the knowledge of data structures and algorithms. Now, we have understood the need for data structure. So, getting into data structure. Data structure is a way of organizing data items that considers not only the elements stored but also their relationship to each other. In general, we can call a program to be an algorithm plus data structure. So whatever the problem we are in need to solve, we should combine the algorithm with the appropriate data structure to get the necessary output. Classification of data structure. So now let us understand what are all the various classifications of data structures available. The first level of classification is primitive and non-primitive data structure. Under primitive data structures, we have the basic types like integer, float and character and pointers. In non-primitive data structures, we have two types. One is static and second one is dynamic. Static, we have arrays and structure, and getting into dynamics, it has been classified into two more things, which is linear data structures and non-linear data structure. In linear data structure, we have the various data structures like stack, queue and linked list, and in non-linear data structure, we have trees and graphs. Getting into primitive and non-primitive data structure, primitive data structures are the data items which can be directly understood by the machine or the computer. Non-primitive data structure, the machine will not be able to understand it directly. And getting into linear and non-linear data structure, in linear data structure, the data items are arranged in sequential order. In non-linear data structure, the data items are arranged in some hierarchical relationship. So this is the overall classification of data structure with the difference between the different classifications that has been given here. Comparison of linear and non-linear data structure. As we know, in linear data structure, the data items are arranged in sequential order, and in non-linear data structure, the data elements are arranged in hierarchical manner. In linear data structure, as it is arranged in sequential manner, we will be having a pointer pointing to the previous element as well as to the next adjacent element. But in non-linear data structure, the things are arranged in a hierarchical manner. In linear data structure, single level is involved, whereas in nonlinear data structure, multiple levels are involved. Getting into the implementation of nonlinear data structure is somewhat complex when compared to linear data structure. Nonlinear data structure is complex in comparison to linear data structure. In linear data structure, data elements can be traversed in a single run. As it is having only a single level, the entire elements can be traversed within a single run. But that is not the case when we move on with the nonlinear data structure. The data elements cannot be traversed in a single run. In linear data structure, memory is not utilized in an efficient way, whereas in nonlinear data structure, memory is utilized in a very efficient manner. The examples of nonlinear data structure are stack, queue, linked list. Examples of nonlinear data structures are trees, graphs and set. Getting into the application of linear data structure, application software development is the main thing where linear data structure is being used. Application of nonlinear data structures are artificial intelligence and machine learning. Basic operations of data structures are inserting, deleting, traversing and searching. Inserting refers to adding a new element into the data structure. Deleting refers to removing an element from the data structure. Traversing refers to visiting each and every element only once during the searching operation. And searching refers to finding a element in the given data structure. Abstract data types. All data structures can be represented as an abstract data type. So let us understand what an abstract data type is. ADT is a set of objects together with a set of operation, which means that an abstract data type in data structure is a kind of data type whose behavior is defined with the help of some attributes and some functions. For example, if we take a stack, we have how this insertion and deletion has to be performed and what are all the elements that has to be shared in a stack. So the behavior of that stack is being determined with the help of some attributes and some functions. The formal definition of abstract data type is, it is a data type that is organized in such a way that the specification of the values and the specification of the operation on those values are separated from the representation of the values and implementation of the operations. Implementation of data structure. Whatever the data structure it might be, it can be implemented in two ways. First one is array-based implementation and second one is linked implementation. Array-based implementation is static and linked implementation is dynamic. Static in the sense, we will not be able to grow or shrink the memory allocated. Linked implementation, we don't have any problem in adding new elements as well as we can delete the element if that particular element is not needed, so that memory allocation will also be freed as it makes use of some pointer concept. So linked implementation is much more better when compared with the array-based implementation. Now let us see how the array implementation is being done. For array implementation, we will be making use of an array. As you all know, array is a collection of similar data items that are stored under a common name. So we will be able to make use of an array for representing a data structure. For stack, queue, tree or graph, whatever the data structure it might be, it can be represented in terms of an array implementation. As already mentioned, when we make use of array implementation, it is a static implementation. For example, in the given example, the memory that has been allocated here is starting from 0, 1, 2, 3, 4 and then 5. Right? So totally 6 memory locations are being allocated. So I will not be able to increase or decrease the memory allocation if it has been implemented in terms of an array. So this is the great disadvantage of making use of array implementation, which makes us to move to the linked implementation. Linked implementation. For linked based implementation, in C or C++, we will be making use of a self-referential structure. A structure which refers to itself is called as a self-referential structure. Here, we will be making use of a structure called node with two different parts. One is the data and second one is a pointer, which we normally call it as a link, which will point to the next node in the given data structure. By making use of this self-referential structure, we will be able to go with the linked implementation. In addition to the self-referential structure, we need to know how to dynamically allocate memory and deallocate the memory. In C, we will be making use of a function like malloc for doing the memory allocation and free to remove the memory that has been allocated. So the example that has been given here is for the structure node, the memory is being allocated based on the size of the struct node. So whenever we are in need to insert a new element, we can do the allocation, and whenever we don't need a particular element, we can free it. So we won't be finding any difficulty with respect to memory wastage over here. Now let us understand the difference between the array and linked list. Arrays, the size of an array is fixed. In linked list, the size of the list is not fixed. Getting into array, we have to specify the number of elements during declaration itself. That is why we mention the array to be a static. For example, if you are in need to store 100 elements, we will be allocating a memory like 100. But in meanwhile, if we want to add one more element, that is 101 element, we will not be able to do it with the help of your array. But that is not the case with the linked list, because we are not going to specify the number of elements during declaration. whenever we are in need of a particular element to be inserted, memory will be allocated dynamically, and whenever we delete an element, the memory will be deallocated. Getting into arrays, it occupies less memory than a linked list for the same number of elements. But in linked list, it occupies more memory. It is because in array, for storing an integer data type, we just need 2 bytes. But getting into linked list, as linked list is a node where we'll be having two main parts. One is data and second one is a pointer pointing to the same structure. So for storing the data 2 bytes, and for the pointer we are in need of additional 2 bytes. So for storing a single element we are in need of 4 bytes. So this is a basic difference between the array and linked implementation. Getting into array, inserting a new element at the front is potentially expensive, because when I try to insert an element at the front of the array, I have to shift all the elements a step backward so that I can make room for the new element. But inserting a new element at any position is not at all a problem in linked implementation. It can be carried out in a very easier manner. Similarly, deleting an element from an array is also not possible. But in linked list, deleting an element is possible, and it can be done in a very easier manner. Now let us go through few popular data structures. List. List is a linear data structure, and it can be called as a collection of data items in which insertion and deletion can be done at any place. List can be implemented in terms of array as well as by making use of the linked implementation. Stack. Stack is also a linear data structure which follows the principle of last in, first out. That is, the element which is entered or inserted last is the one which will be deleted first. Examples of stack can be called as anything arranged one above the other can be called as an example of a stack. And in stack, both insertion and deletion can be performed at only one end called top of the stack. Queue. Queue is also a linear data structure which follows the principle of first in, first out. Examples of queue are our real-time examples. Wherever we stand in a queue, the person will be inserted at the last and the person will be deleted from the front end. So in queue we will be having two ends called front end and rear end. In the front, deletion will be done, and at the rear end, insertion will be done. Tree. Tree is a non-linear data structure in which the data items will be stored in a hierarchical way. Each node is associated with the key value with parent nodes linked to child nodes. Here we have one particular node called root node, which is the ancestor of all nodes in the tree. Graph. A graph is a data structure in which we have a collection of vertices called V and a collection of edges called E, which is represented as an ordered pair of vertices U, V. Example of a graph data structure can be anything connected with each other. For example, the social media networks, Facebook, Twitter, everything can be called as an example of a graph. I hope this lecture makes you to understand the basics of data structures, like what is data structure, why do we need data structure, what are the various classification and how it is being implemented, with what is the difference between linear and non-linear data structure, and what are the various popular data structures available. Thank you.